All right, I'm going to get started here just for time's sake. We have about an hour to go through apple trees and to cover the new material for today. I'll try to get through apple trees as quickly as possible, but also we'll stop to explain things. At most, I can only spend 30 minutes on apple trees, so at 11:20, I have to move on to the new material. So let's clone or download this, which I've already done. So I've cloned down apple trees from where it lives originally on the internet and brought it down to my machine. Checked out a branch called John's branch in Foxtrot. Let's kind of take a look at how this is just going to work. So it's just apple tree number one. We're just worrying about apples. So up to this point, we've just been doing classes where it was like, class address, it takes in a whole bunch of arguments, and then it just merely just prints out something at the very end. And that's not usually how most object orientation works. Most object orientation is going to talk with other classes. It's going to have methods within it to do certain things. And that's what we're going to be doing here with this apple trees today. So release 0 just says we want to implement the apple tree and apple classes. So when we take a look over here, remember we only had one file up to this point, probably a JavaScript file or a Ruby file. Now we're dealing with much more things. So we have this apple tree.rb over here. And we have an apple. Do I have an apple.rb? No apple.rb? Let's take a look.
No.
So it looks like implement the apple tree and apple classes. Looks like I'm missing an apple class, so I'll do apple.rb. Save this in its spot and create a class called apple. I'm using adder reader, writer, and accessor so that we can call tree height and tree age to get a tree's age or height respectively. Which one of these methods should we be using and why? So a tree has a height and a tree has an age. Is that something that we're going to read, write, or both?
Both.
What's that? I have both and I have read. Which one? It's both, yeah, because a tree is going to age and it's going to increase in height over the years, right? That's something that's changing over time until a certain point. The trees won't grow forever, but at a certain point, but most of the time I'm going to be growing it, yeah.
In the original file, the apple tree file had an apple method at the bottom of it.
Oh, my bad.
Is it standard practice that each class should have its own file?
Oh, that's a great question. So the question was, I have inside of this apple tree.rb, I have a no apples error, I have the apple tree, and I have an apple. Should I be throwing everything in one class, or should I do everything in multiple files? And the answer is, let's put it in multiple files. For right now, when I'm showing it, I'm going to put it into multiple files. I think the purpose of this, when I first originally wrote it a while back, was just to make sure that like you had everything you needed on one page so that you didn't have to worry about other files. But since I'm doing this, I will move it from over here to over here instead. Now, so I have two fully separate things. One of them is an apple and one of them is an apple tree. So an apple tree has a certain height when it's first born and a certain age when it's first born, and those things can be overwritten and read. So when I initialize my tree, I'm going to initialize it with a height of 0 and an age of 0. Because when you first plant a tree, it's a seed and it has no age yet. Like you're just going to plant it in the ground and then it's eventually going to grow up. So I have at height equals height, at age equals age. And because these are both readers and writers, I'm going to change this into an adder accessor, height and age. So right off the bat, when I create a new tree, if I don't pass in any arguments, I know that height starts at 0 and the age starts at 0. And then over time, I know that it's going to grow older and it's going to grow a little bit taller. Sean?
I just want to double check because this is ugly sometimes.
Yeah.
Can you at height put equal 0 inside of the parameter part, but just in like, you know what I'm saying? Like there.
Like here to start with?
Yeah, and not actually have parameters.
Yeah, that's totally fine. You can do both. So the question was, do I need to default the arguments here, or can I just set it to 0 to begin with? You can just set it to 0 to begin with.
No one's going to be looking to pass parameters in.
Yeah, that's probably true. That's not a bad idea. Let's go with that. At age equals 0. So when I create a new apple tree, and I don't need to pass anything in. I know that by default, the height's going to be 0 and the age is going to be 0. I like this a lot. This is pretty good. plant a new tree. It's just a seed. It's not tall, and it's 0 age, 0 years old at that particular point. All right. So this one works. Do the same thing with apple class so that we can call apple.diameter to get an apple's diameter. So when I create an apple has a certain diameter. You can pass this in if you'd like, or you can just randomize it on the inside. Which one would you like to do? Randomize it on the inside. So maybe we can just do @diameter equals random number between, I don't know, how many inches in diameter is an apple usually? 2, let's say it starts at 2 and it goes up to, you have those Costco sized Red Delicious apples, right? Like 6 inches in diameter. All right, so we have, is this diameter something that is going to change? Is it something that we're going to read, write, or do both to?
That is just going to read.
It's just going to read. You could technically say it's going to, you can grow your apples to a certain size, but that's just getting too much into the weeds. Let's just say every apple has a diameter and that's it. So add a reader of diameter, and that's about it. So again, we just created a tree. Height when I first create it is 0, age is 0, and the diameters when I create an apple is just some random number between 2 and 6. I should write tests for these methods. For time, actually, let's see how far we can take this. Actually, let's not go that far. All right, that was release 0. Release 1 says implement aging. As a tree ages, it grows taller, and eventually it starts bearing fruit and stops growing, not necessarily at the same time. Some years later, the tree dies and can bear fruit no more. So it says implement a tree age bang method that will age your tree 1 year. Each year, the tree should get some amount taller and then eventually stop growing. You can decide when the tree stops growing. So I think we had some specs to get us started. You see that we have a spec file for every single file that we write code for. So you can see I have require relative apple tree on the very top of this because I'm using the class apple tree inside of this spec file. The apple tree class doesn't exist within this spec file, so I need to require relative to this particular file because that's where this particular thing is defined. So I have age and test, age and height. So this should be fairly simple. It should return the age of the tree. So we already wrote the code, so we're just kind of going backwards here. So we have a tree variable that we can use between all of these different describe blocks. So I'm describing the entire class, and each one of these individual describe blocks describes one individual method that I have. So it should return the age of the tree. So I expect tree.age to equal 0. Same thing over here. It should return the height of the tree. Yes, Sean.
This is just like I'm having a hard time believing that you can write every test scenario until you start coding. So like those things are always going to go back and forth. I don't feel like you could actually think of every single thing.
Yeah. So the comment was like, how realistic is it to write all the tests first and then write the code? Let me pause. I'm not pausing the recording for this. Okay, this is what I'll say. Test-driven development is the best practice overall. You will have far less bugs in your code. You have a clear idea of where you're going. That being said, it's mostly reserved for companies that are very, very wealthy and very large, or companies that can charge for it because it takes a long time and you have to think through everything. Most of the companies I've worked for are saying like, you have this project to do, it's due by Friday. It's like Tuesday. So you have to finish off the code by Tuesday. I'm not going to write by Friday. I'm not going to write all the tests. Like that's just not what I did. I just wrote all the code just to make it work, and then I made sure I tested everything afterwards. So it is, I will say, officially, test-driven development is the best and only way to develop software. In a practical sense, that may not always be the case. That's what I'll say. But for all this, I will try to do test-driven development. So we have written 2 tests here after we wrote the code. Let's just see if this runs. So I'm going to list everything out. I'm going to run rspec apple tree spec.rb. I I have 5 examples and 0 failures right now because all I have is 1, 2, 3, 1, 2, 3, 4, 5. I don't have any tests really, so everything I've written so far works. The next thing it tells me to do is it should increase the age of the tree by 1. And I don't know how to do that. I don't because all I'm used to is just doing expect some tree.height to equal something. But when I age the tree, I expect the tree's age to change by 1. Luckily, there's this concept of matchers. And it looks like it's fairly simple. It should increment the count. Expect, and then inside of curly braces, I'm not sure what that is, something.increment to change the count from one thing to another. So instead of one thing should equal something, I expect when I run this code that something changes. Like when I sign up for, so we'll talk about investments and personal finance coming up, but like if you invest in a stock called VTSMX, there's a $3,000 cap. When you hit $10,000, it'll automatically transfer into VTSAX. So it's like when I invest my money in this particular stock and it reaches $10,000, the test on their end might be when the balance reaches $10,000, I will automatically transfer your investments into VTSAX. So fairly simple. I'll just grab, copy and paste, and so it should increase the tree's age by 1. Paste all of this here. I don't need the if block. I just need the expect block over here. So I expect some sort of curly brace. I don't know what this is, but we'll take a look at it in just a second. So you'll see that you have parentheses and you have curly braces. Parentheses is for evaluating something. Like it's just tree.height. That's an instance variable off. That's an instance. That's an adder reader right off of the object. So I'm just evaluating tree.height. That returns me something. When I need to execute some bit of code in order for the test to run, I'm going to have the curly brace here. So when I run expect tree.age to change the tree's age from 0 to 1. Does this kind of make sense?
Yes.
So expect, when I call this particular method, the tree's actual age, so remember, I don't have a method, I just have an adder reader here. It's going to change from 0 to 1. When I run these tests, I'm going to do that red-green refactor thing. So it's going to turn red. This blows up because nothing changed. But we also haven't done anything in terms of code. So how do I write the code to make this tree get older by 1 year?
So just say age just incremented by 1 every time the age is called.
Yep. So when I'm altering the original instance variable, I have to put the @ sign in the beginning. If I'm overwriting it, then I could just do age equals something else. So let's just see if this works. So again, I just have a height and age defaulted to 0 to begin with. When I age the tree, the overall age should increase. Run the test one more time. 5 examples, 0 failures, so I just passed that particular test. Moving down, it should increase the tree's height. All right, so similar thing, I'm just going to copy line 20. When the tree ages, I expect the tree height to change from 0 to 1. I don't know, how much do you want the tree to grow every year? A foot? 1 foot? It's up to you. Yeah.
Let's do 8.
8 feet.
Yeah.
I'm gonna split the difference right down the middle. Just say 3 feet. It's a very progressive one. Okay, so I'm increasing the age. I'm gonna run this test. It's gonna fail. The height of the tree did not change. So what do I have to add to this age method over here? Add height plus equals 3. All right. I run the test one more time. 5 examples, 0 failures. Let's continue. Let's go back over here to the README real quick. So height returns the current height. Age returns the tree's current age. It ages the tree a little if it's able to grow. So let's think of that for a second. The tree is going to grow until a certain point, right? Trees do not grow forever. Apple trees in particular do not grow forever. right? At one point, they just stop growing. They hit their max. It's kind of like human beings. We hit our growth spurt, and then we hit our max. We're not going to get any taller. I'd like to be 6'4", but I am not. Where should I guess, how do I write the code in order to say when the tree is going to stop growing?
We just did a if less than whatever the final age is, and then a counter inside of there with all the variables.
That is one way of doing it. Let's just say how tall are apple trees on average?
Say 70 feet.
Oh, you're talking about height?
Yeah, height.
Oh, yeah, just
Yeah.
whatever that
Let's say that the maximum height is equal to some random number between 20 and 25.
Yeah, 15 and 25.
15 and 25. All right. So when I create the tree and I plant it into the ground, it's a seed, right? So there's no height, there's no age. The maximum height that this particular tree can eventually grow to is somewhere between 15 and 25. And what about their maximum age? Like, how long do apple trees live before they die? I have no idea what the answer to this question is.
Just say 15 years.
Okay. Let's say maximum age is equal to some random number between 10 and 15 years. I don't actually know how long apple trees live. So I'm going to age this thing eventually until it is dead, right? Like at one point, I'm going to keep aging, I'm going to keep aging, I'm going to keep aging until what point? Until it hits the maximum age, right?
Yeah.
So how do I write it? How do I write that code inside of here? Because that's what this test is saying. So let's say I have a tree, right? So expect tree dot, let's say I do, let me do one more variable at tree. Actually, no, let's write the test first. All right, so we age the tree, so it increases the age by 1. We increase the tree's height. Every year it's going to grow by 3. We have this concept of it should kill the tree eventually. So at a certain point, it should no longer grow any older. How would we write the test for this?
What to call the tree dead, tree.dead.
Yeah, I have tree.dead. I can put it over here. Should kill the tree eventually. Yeah, this should probably go further down over here. So when the tree is first born, is it going to be dead?
No.
No, right? So I'm going to do dead equals false. It's pretty simple. So maybe I'll add a test real quick that says it is not dead when first initialized. So I expect the tree.dead to equal false. When I first create the tree, remember this tree is this tree.new, I expect it to not be dead. Fairly simple. So I created a instance variable over here. Is this going to be a reader, writer, or both?
Both.
Both, because I'm going to read it and I'm going to also write to it. At one point, I'm going to age it, and then it's going to flip from being falsely dead to truly dead. So I'm going to add this dead here as well. The maximum height and the maximum age, is that something that is going to be read, written, or both?
Just going to be red.
Just going to be read. I like it. Maximum height and maximum age. So I have the tree is not dead when it's first initialized, and it should kill the tree eventually. So if I do, let's say 50 times do tree.age, expect tree.dead to equal true. So when we run this, these two new specs, we're going to have 2 failures, and we're going to go back and try to fix those. So we have these 2 failures going through right now. How do you determine when something is dead? In this, well, that's true. Actually, let's get rid of this dead thing. I'm sorry. Sorry, I got rid of the dead thing.
When it can't grow anymore.
When it can't grow anymore. Okay, so I have a maximum height, a maximum age, and I have height and age as well. How do you know when something is dead?
So
Using those bits of information.
You reach maximum height.
What's that?
When you reach maximum height and age.
When you reach maximum height and age.
Maybe just maximum age.
Just maximum age. I like that one a little bit better. So basically I'm just comparing, is my age greater than the maximum age? That's about it. Like the maximum age for a human being is what, 120 years old? So if you're over 120 years old, you're probably dead. Like that's just what it is. So that's what I'm doing here. I'm just comparing my current age of the tree and comparing it to the maximum age. So I expect when the tree is first born, since the maximum age, the age is 0 at that point, it's less than this maximum age that lives on the tree. Then I'm going to age the tree 50 times, which is way more than the maximum age over here. Let's just age it 20 times. It doesn't matter. Or 16 times at that 20. I'm going to expect the tree to be dead at that particular point. I've got my 6 examples and 0 failures there. All right. I'm going to age the tree until a certain point. When is that? Like that point is until it's dead, right? So I'm going to write that real quick. Until dead. And again, I'm just calling this method down over here. I'm going to increase the age by 1. And until, maybe we'll do reached max height, I'm going to increase the height. Create another method down here called reached max height. I'm going to compare, is my height greater than or equal to maximum height? You kind of see these small individual methods. It's called single responsibility. So I could have written all of this code inside of here, but it's a little easier just to read as a human being, like until the tree's dead, I'm going to increase the age by 1. Until the tree reached its max height, I'm going to increase the height by 3. Now we're going to, I have to finish this in 8 minutes. Now we're going to move into this concept of any apples. At what age are trees able to produce fruit? Take a random guess. I don't know the answer. 2 years old. Okay, let's just say that we need to keep track. Every single tree has a certain fruit-bearing age, right? So let's say at fruit-bearing age, let's just say it's equal to 4 years old for the sake of argument. Is this going to be something that is going to be read, written, or both?
Read.
The fruit-bearing age, let's say for all trees, all apple trees of all time is going to be 4 years old, just for the sake of argument. So I'm going to write a test to see if the tree has any apples. So I'm going to, let's just say, I'm going to first start off with a tree that's very young. So it returns false if it is too young. And then it returns true if it is at the fruit-bearing age or greater. So when I first plant a tree, I expect tree dot any apples to equal false. Right off the bat, because when the tree is first planted into the ground, it has no fruit. When I age the tree, let's say 5 times, 5 times tree.age, and I say expect tree.any apples to equal true. Because I've aged it 5 times, it's past the fruit-bearing age. It's going to now return true out to me. So when I say any apples, this one is actually fairly simple. We just say age is greater than or equal to fruit-bearing age. That's all we need to really see if it's able to have any sort of apples. our spec, apple tree spec, everything blows up. Expect tree.age to have changed to 3, but it is now 21. It's because I've aged this so many times. Oh, it's not until. Sorry. It's unless. My mistake. There it is. All right. So now we're going to move into this. Now we're going to move into this pick an apple kind of method, and this is the big one, the one that's like the most difficult to kind of wrap your mind around. It's the idea that I'm going to be basically talking with another class. So I have an apple tree here. The apple tree is in charge of itself. It's just in charge of aging, returning if it's dead. It has to reach the max height, and so on and so forth. It's not in charge of individual apples at all. The individual apples are in charge of their own diameter, and that's about it. All right. So when my tree reaches actually this is not correct. My mistake. A tree also has apples. Every single apple tree has apples on it, right? Hopefully every single apple tree has apples on it. And then they grow at certain points, and then you go pick them in, Wisconsin or whatever. But at the very beginning, every tree does not have, every tree has 0 apples. And over the years, it grows and grows and grows until it reaches a fruit-bearing age, and then it starts to grow many different apples. Which method do you think that apple growing is going to go into?
Probably age.
Probably age, right? So every single year, the tree is going to age. Unless it's dead, I'm going to increase the age by 1. And then, unless it reaches its max height, I'm going to increase the height by 3. If age is greater than fruit-bearing age, I'm going to just shove in some random number of apples. I'm just going to do apples dot push. Let's just say rand 5 and 10 times do. So again, I plant my tree in the ground. It's just a seed. It's 0 height and 0 age. It has a maximum height that it can grow to, has a maximum age that it can reach before it dies, and it has a fruit-bearing age of 4. Every single apple tree, for the sake of argument, is going to bear fruit around 4 years old. It has no apples to begin with. So I'm going to age it every single year. Unless it's dead, I'm going to age it by 1. And once it reaches, actually, I think we can wrap this whole thing in unless. So unless it's dead, I'm going to increase the age by 1, and then unless it reaches the max height, I'm going to increase its height as well. If the age of the tree is greater than the fruit-bearing age, greater than or equal to, I'm going to push 5 apples into its apples array. Now, we have 2 different classes inside of one class. So we have the apple tree as one class, and we have apple as another class. Because apple no longer lives on this particular file, I need to require relative up top because I'm using another file as class. Require relative for apple. Going back to the spec over here, it returns false if it's too young. Actually, any apples is actually going to be much easier. Apples.present. That's about it. Is there anything inside the array to begin with? So at the very beginning, there's no apples. When I age the tree 5 times, I expect there to be anywhere between 5 and 10 apples inside of there. Let's put a pry.
Go. So dot present is a method Is it built-in Ruby method?
Yep, dot present is a built-in Ruby method that basically says, is there anything inside of the array? Just to show that
For
off.
only arrays or
Just arrays, yeah. So if I have a equals this, if I do a dot present, sorry, a dot, shoot, it's not present. Ruby methods array. We just want to see if there's anything inside of there. I'm sure there's one thing that says, is there anything inside of here?
Empty.
Hey, that's a good one. Yeah.
I guess that's the opposite.
Yeah, that's the opposite here. So the bang negates everything. So this will return true if it's empty. So I'm basically saying, is this not empty? Or I can just say empty equals false. Let's make it a little bit easier. I still think these tests that I wrote are still good. So let's find out. We've got two undefined method or apples. Did I mess something up? Oh, I didn't add it to the, let's just put it as an accessor for now. Okay, 8 examples, 0 failures. And finally, we have this pick an apple thing, which basically says, if there are no apples, I'm going to raise an error. Like you can't, if you go up to a tree that has no apples on it, you can't pick an apple from it because there's no apples on it. So it's going to return an error like actually there are no apples. Otherwise, I'm going to return apples. So I'm just going to do apples dot pop. I'm just going to return that one to you and then destructively raise it. So I want to write tests to see that an apple is picked. And I also want to raise an error when there are no more apples. So I want to test those two things. It raises an error when there are no apples. And then it returns an apple object, when you pick an apple. So I'll work on this one first. So let's say we age a tree, so 5 times. I expect tree.pickAnapple.class to equal an apple. Let's see if this runs here. So that still runs. Let's actually put a binding price so that we have an idea of what's going on. I'm going to require relative and then require pry up top. I'm just going to run line number 56 because I don't want to run all of them. I'm going to press up and just specify the number as :56 here on the bottom. And that'll just run one particular spec. So I'm here at this particular point. I have a tree. The tree, this is what it looks like when we create an actual object. The tree, the current age is 5. It has all of these different apples inside of its apple tree. It has a fruit-bearing age of 4, height of 15, maximum age is 12, and the maximum height is 20. So this is my entire apple tree that I've created so far. And you can kind of see I have all of these different apples inside of here. When I do tree.pickAnapple, it's going to pop off this last one, this one ending in 0298 with a diameter of 4. 0298, diameter 4. And when I look at the tree again, you can see that 0298 with the diameter of 4 is no longer within this particular array of apples because I've popped it off and it's no longer part of the apples that are available on my particular tree. I'm going to write the test for this one real quick and then push it up and then dive into the next stuff as quickly as possible. So this one is going to work. I'm going to expect to raise error spec. All right, I'm just going to run this. It's expect 20 times tree dot Let's see if this works, and I'll explain it in just a second. Okay, 10 examples, 0 failures. So basically what I did was I aged the tree until it reached a fruit-bearing age, and then I picked 500 apples. Obviously, this tree is not producing 500 apples. And at one point, it's going to blow up and say there are no more apples for you to pick. So it raises this particular error. That's what I'm testing here. I'll push this up in just a little bit. I want to jump over into CSV and kind of teach something new. So let's go back one. So with that, let's talk real quickly. What is a database in your understanding? How would you explain a database to a young person?
I would explain it as a collection of information.
Collection of information. I like it. All right. What else? John?
Like a spreadsheet.
It's kind of like a spreadsheet. Yeah, you can. Yes. A database is more or less like a spreadsheet, but it's indexed, so you can access stuff really quickly. You don't have to do like a Control F to look for things, and it's organized much easier, and it has its own language so that you can query it much faster. We're not going to do databases quite yet, but we're going to do something called, we're going to be reading and writing to a file. It's kind of similar to a database in the sense that like the data that we write into the database into this file will stay the same unless we decide to change it. And today what we're going to be using is a format called CSV. So has anyone seen CSV before? If people have worked in Excel, there's an export as CSV. It stands for comma separated values. And it's basically, CSV is basically an Excel sheet. That's all you need to think about. It's an easier way for developers to read a spreadsheet. Kind of like a .txt file is a text file. It's an easier version for developers to read than a docx file or a doc file, like a Microsoft Word. So instead of having all that fanciness, it's just comma separated values. So if I have 1, 2, 3, then I would have inside of a spreadsheet, like cell A1 would be 1, cell B1 would be 2, and cell C1 would be 3. So let's think about, I'm gonna require, actually, CSV example.rb. I'm gonna save this inside of CSV. I'm going to require the whole CSV library at the top of this. Let's talk about, well, it's currently basketball season. So let's say we have 2 teams in the playoffs. So let's say, what are the 2 teams that are in the playoffs now?
Cavaliers and Celtics.
Nope, we have the Warriors. Do people watch basketball? Okay, I think it's Warriors and Rockets, if I'm not mistaken. All right. Yeah. So let's say that the first thing we're going to enter is going to be the Warriors. They have a win record. Actually, let's just jump into it. What is Warriors and Rockets? So we've got the Warriors. They are win-loss record 2018. I don't know how to read this. Let's just say, okay, it looks like Golden State is up 1-0 right now. So they have, let's just say we start with ID number, team name, win record, and loss record. And then we have, number 1 is going to be the Warriors. They have a win record of 1 and a loss record of 0. The next team after that is the Rockets, who have a win record of 0 and a loss record of 1 at this current moment. Let's say I have this data and I want to put it inside of a quasi database. I'm going to write it to a file here. Using the CSV library, Ruby CSV library, I can use some of these methods here on the left-hand side to take all of the data that I have right over here and write it inside of a file. So let's take a look. I'm just going to read. It looks like this is reading one line at a time, all the lines at a time. Oh, here's the writing. So I'm going to write to a file. So I'm just going to copy this. I don't know what this is, but I'm just going to copy it and take a look. So it says the CSV library is going to open a file. It says path to file. Okay, so maybe I'll call this mba.csv. And this weird WB, I'm not sure what that is. So it's going to do something with the CSV. I'm going to put a row of CSV data as an array, and then I'm going to put another row's worth of stuff inside the CSV. I kind of get where you're going with this. But what is this WB? Inside of your curriculum, no. Inside of your curriculum, there are a bunch of extra arguments that you can pass in. So these are the ones that we're going to be doing. There's read only, there's read and write, there's write, read write with a plus, append to the very back, append with read and write binary file mode. Which one of these do you think we should use to write to the file? W. Okay. We can use WB if you want to, but we're just going to use W for now. Using the data that I have inside of here, how do I shove all of this information from Teams into the CSV?
You just say CSV shovel teams.
Well, I have a multi-dimensional array here, and I want each individual line. And I can't flatten because this is one record, this is another record, this is another record, and so on.
So CSV shovel teams CSV.
So you said CSV shovel teams CSV like that?
Yes.
No. So again, teams is a multi-dimensional array. It's an array of arrays. That's what it means. So this is a this is a two-dimensional array because it's one array full of one layer of arrays. So I need to iterate over each one of these things and get to each individual record. So it's going to be teams.each do row. So again, let's read through this. Require CSV. CSV, this class over here, is not written inside this file. So I need to bring it in from Ruby. I created a multi-dimensional array, which is an array of arrays with different information. The first array says the ID, the team name, win record, and loss record. And I have, number 1 is going to be the Warriors with 1-0, and number 2 is going to be the Rockets with 0-1. From there, I'm using the CSV library to write to this particular file called mba.csv. You can see that it doesn't exist quite yet. And this little W found in your curriculum is a little extra little mode that you need to pass in order to tell, am I reading to it or am I writing to it? We saw this W, it says it's write only, so I'm going to be writing to this particular thing. The whole file is saved as the variable CSV, and I can change this to whatever I want. I can change this to poop. You can change it to whatever you like. I'm just going to keep it as CSV for now. I'm iterating over each one of these individual teams, so each individual array, saving it as row and shoving that thing inside of CSV. So let's just see this happen. When I list out everything, I just have one file. When I run Ruby CSV example, it runs through everything, and when I list everything out again, I have mba.csv. I'm going to open this real quick. I'm going to open this with, do I have Excel? I don't have Excel. But you can kind of see when I just press the small little space bar, you can see that I have ID, T name, win record, and loss record with each individual thing. I'm writing to a, so I'm just writing to a file here. Let's say that I wanted to add one more team in by accident. Let's say my favorite team growing up was the Knicks, the New York Knicks, who are absolutely garbage today. All right, let's take a look at Knicks record 2018. Let me jump into ESPN.
29 and 53.
What was that?
29
29 and
and 53.
50. God. Okay. All right. So I know that I need to open this file that I already wrote, and I want to throw this extra record at the very end. So I'll get you started. I want to csv.open mba.csv. I know I need some sort of extra flag. Do CSV. I'm going to do CSV. Number 3 is going to be the Knicks. And 29 wins, 53 losses, because they are terrible. Let's look over here. Is there one of these flags to basically push something to the end of a file rather than overwriting it?
A.
Yeah, it looks like A, append write only, starts at end of file if the file exists. Seems fairly promising. So we're adding this little A in its place here. And we're going to run this whole thing again. If all goes well, I'll see ID 1, 2, 3 with all of my teams here. So I'm just gonna, let me just remove the mba.csv, list out everything. I just have one file, run Ruby, csv example.rb, runs through, doesn't look like anything is broken. And let's open this up. When I take a look at what it looks like, there I have my, in tiny little letters, ID, team name, win record, loss record, and it's appended correctly. If I want to write something to the very beginning of a file, how would I do that?
R plus.
Yep, read write starts at the beginning of the file. So if I wanted to put the Knicks to be number 1, I can just change this to be R plus. List out everything, remove the MBA. Run Ruby CSV example, open up everything. And you can kind of see here I have, oh God, my very first thing is going to be the 3 Knicks 2973. It doesn't make any sense, but it's like I moved it to the very top. So just these tiny little flags over here, you can like put data at different points. Interesting.
With the simple solution of that, like where your headers are not out of place, if you want to do something very similar to that, would you just say like R plus, and then would you be able to have it some additional input to correct that?
Well, it's kind of, ask the question one more time.
So in that specific example, you use that mode R plus to put it at the beginning. Let's say you wanted to do exactly what you just did, but you wanted to keep that first array as your header for that printout. Is there something you could do? Is there something in addition to R plus, like some sort of like R plus, plus 1 or something?
Let's see. Not that I can see from here, but actually that kind of takes me into my next thing.
Oh, okay.
Let's take a look at how to read. So oftentimes we're going to be writing stuff to a CSV file, to a database, but we also need to be able to read stuff out of a database. So I'm going to just keep everything the same. You can see mba.csv is going to, so it's just there. I'm going to open up IRB real quick and run require CSV. And I'm going to more or less look inside of this to see how do I read from a file. So it looks like, I can just do .read with this particular path to CSV file. Let's take a look at what that looks like. So if I just do csv.read and I'm going to do mba.csv, you can kind of see I have all of that stuff that I originally had. I had, the 3 Knicks 2953. I have this random. I don't like this. I'm going to move it back to what it was. What was it? A, if I'm not mistaken.
Yes.
RM MBA. Ruby CSV example, IRB, require CSV, and then CSV.read, MBA.CSV. So I have my first thing is the ID name, ID, team name, win record, loss record, and then all of my teams that I just had there. From here, I can iterate over each one. I can add a bunch of stuff, but this is the way that I would read it. If I wanted to read everything all at once, this is what it looks like. There's another way to read it using the for each. So let's grab this and just throw it over here. For each row, let's just P row. So I can iterate over each individual one rather than having an array of arrays. But let's actually do something else real quick. So I'm going to put a binding pry and end here. I cannot call pry within here. Require CSV, require pry. So I run through everything. You can kind of see that if I were to, I'm now inside of MBA.CSV. I could take a look at each individual row. Each individual row has, I can, instead of iterating over an array of arrays, I can take a look at each individual row. So the first time through, it gives me the ID name, the ID, the team name, win record, and loss record. Second time through, I get that Warriors 1, 1, and 0. Third time through, I get my Rockets, and then finally my favorite team, my Knicks, at 29 and 53 at the very bottom. You can kind of see like this particular bit of data. We can this would include things like. I mean, it's fairly simple. If I were to even just take a look at the attendance sheet for Code Platoon, I can alter the data pretty quickly inside of here. If I were to read through this, it's fairly simple. Like my first row would just be this. My second row would be empty, and then I would have each individual person. If I wanted to get all the email addresses in a non-GUI way, I could just do like row at index 1. Each row at index 1 is going to be the email addresses, so I can collect all of those email addresses really, really fast. Yeah, so this is a little bit of how I would do that. I'm going to stop recording here because I don't think anything I'm about to say is terribly useful, but I kind of want to show you an example with the city of Chicago's data. Actually, I'll keep recording. Why not? City of Chicago, salary CSV. So the city of Chicago has a whole bunch of data, and they print all of that out. You can actually be super nosy if you'd like, and from here, grab all of the names, salaries, and position titles for every single person who works for the city of Chicago. I'm going to just download this. I don't know how. How do I download this? Before downloading, or can I download? Oh, there we go. So I'm going to download in various formats. You can kind of see there's a whole bunch of, like, developers don't use Excel. They use CSV. So I'm going to download this whole thing as a CSV file. You can kind of see, here it is. It's huge. Like, it's completely unreadable. And from here, let's say I just wanted to get like the top three paid people in the world. So we have this download. Let's put this up here. Let's just call this nosy.csv. I'm going to throw it inside of CSV. You can kind of see I have all of the names, job titles, department, full or part-time, salary, hourly, typical hours, annual salary, and hourly rate. inside of my CSV example here, I'm just going to do csv.read noz.csv. I'm going to put a binding pry right here and comment out everything else. So I've stopped over here. I'm just going to highlight this particular line and just paste it in here. So it looks like there's no such directory or file noz.csv. It's right there, isn't it? Oh, I added this thing. My mistake. Okay. Let's clear the screen and do that one more time. You can kind of see that I now have all of the things inside of here. If I wanted to just grab the annual salary of everybody, all I have to do is 1, 2, 3, 4, 5, 6, 7. So if I just do a.map, a each do x, x at 7. Oops. Let's just say a each do row. All I have to do is more or less write a small little script and I'm able to get all of these salaries. So I grab this, just throw it in here, and I'm going to take a look at my salaries array. You can kind of see what I've got. Oh, this is hourly rate. Let me take a look at, it's going to be 6, my mistake. 6. So I've got my binding pry. I'm going to read the CSV. And then I'm going to create a salaries array that's empty. And I'm going to iterate over each one. Because I know it's always fixed at that 6th location, I'm going to basically iterate over each row and push their salary into this array. Salaries equals this. Now let's take a look at the salaries we've got. Now you have all of the information going straight down. I'm going to get rid of all the nils. So compact. I'm going to get rid of the first one. Shift.compact. Salaries. Compact. You can kind of see every single salary that we've got here. From here, it's a little bit more difficult and involved than I have time for, but I would turn all of these into integers and then basically just sort to see the top 3. I'm not sure if it's just .map to I. Nope, I can't do it because these are all strings. But you can kind of see just the sheer power that you can do it really, really quickly. I mean, obviously I know that you can just do it .sort on inside of Excel, but this is how you would do it inside of the code. This is the stuff that's going on underneath the hood of that Excel file. All right, thanks for listening to me talk for so much this morning. We have a few challenges for today. Just 2, word guess CSV. So this one you're going to be reading words from a CSV file and guessing if it's correct or not. And then ice cream and freezers is basically a giant OO type of a giant object orientation, kind of like the challenge, kind of like Apple Trees was yesterday. With that, today's Tuesday. It's going to be a pairing day. So find someone you haven't worked with and we'll get started.